All right, hello and welcome. This is going to be our lecture video for March 31st. Going to be talking about geometric series today. We'll start with some warm-up problems about geometric sequences, and then when I say series, that means that we are going to be summing them together into just a single number. So this says find the common ratio. Because it says common ratio, not common difference, we know it's a series or geometric sequence. And then we want to find the term named in the problem. So it gives us the fifth term and the second term, gives it to us out of order. That shouldn't matter too much. We want to find the 10th term. So what can be really useful is figure out how many steps are between the second term and the fifth term. So I'm just going to write out a sub 2 here, and then I'm just going to count 3, 4, 5, and this is a sub 5. All right, so to get from a sub 2 to a sub 5, we need to make 1, 2, 3 steps. And you'll notice it's always going to be the difference there, but sometimes we like add 1, so I still think the picture is really useful here. And that means that I'm getting from this term here to this term here by multiplying by the same common ratio 3 times. All right, a sub 2 is 2, a sub 5 is negative 16. And so I can set up an equation like this. 2 times r times r times r equals negative 16. All right, I'm going to divide both sides by 2 here. And I'm also going to collapse that r times r to be r cubed. So r cubed equals negative 8. To get rid of a cubed, we can take the cubed root or raise to the power of 1/3. So I raise to the power of 1/3. And I know this one, negative 8 to the 1/3 would be negative 2, because negative 2 times itself 3 times is negative 8. R equals negative 2. So that answers our first problem. The common ratio is negative 2. Now I need to just keep going up until I get to a sub 10. So a sub 10 is how many steps away from a sub 5. So a sub 5, 6, 7, 8, 9, 10. This should be 5 steps. Let's double check. 1, 2, 3, 4, 5. And so I can take my a sub 5, negative 16, and multiply it by negative 2 5 times. And this can just be plugged straight into our calculator. Be careful with your parentheses there. Negative 2 to the 5th power is a negative 32 times negative 16 is a 512. All right, so 512 was a sub 10. All right, here's a question I came up with to go back to arithmetic sequences, but to just really challenge you. Find the sum of all of the multiples of 11 between 2,400 and 3,100. Okay, so what's the first multiple of 11 greater than 2,400? Well, let's see if 2,400 is divisible by 11. So I do 2,400, I divide by 11, and I got a decimal. I specifically got 218.18, and this is pretty low, so I want to go up quite a bit until I get, well, actually I know that my next multiple will be 219 times 11, so I'm just going to do 219 times 11 to get that the next multiple of 11 greater than 2,400 is 2,409. That is a multiple of 11 greater than 2,400. All right, maybe off to the side I'll even write that that is equal to 219 times 11. So it's a multiple of 11. All right, now what's my biggest multiple less than 3,100? Well, let's do 3,100. Too many ones in there. Divided by 11. Maybe it will be a multiple. It's not. But I get 281.8, so I know it's going to be 281 times 11. So 281 times 11 gets me 3,091. That's the biggest multiple of 11, less than 3,100, 3,091. All right, so that's my biggest term. That's my smallest term. All right, so I've got most of what I need for this formula, but now I need to know how many 11s are going to be between these two numbers. counting up by 11, how many steps does it take me to get there? And to do that, you do the bigger number minus the smaller number divided by our common difference of 11, and then you always add 1. This is where that you got to remember that plus 1. It's kind of tricky, but it's because you're counting that first number. That's where that plus 1 comes from. So, and this should give us an integer. If not, we've made a mistake. And we get that there are 63 numbers. All right, so now I'm ready to plug this all into my formula for the sum. To do that, I'm going to average the smallest and the biggest number and then multiply by the number of numbers. And this can just be plugged directly into our calculator. 2,409 plus 3,091. Hit enter, divide by 2. I get 2,750 is the average times 63. And I get the sum of all the multiples of 11 between those two numbers is 173,250. Okay, so that really put together everything we've been working on with arithmetic sequences. All right, back to geometric. So our goal today is to be able to add geometric sequences to a certain number of terms. Why? This can help you find the total of something that's growing exponentially. So, something different each day. So this wouldn't really work for money, but this would be like something is happening each day, and it's exponentially more than the day before, and we want to add up all of those occurrences. Okay. If you want to follow along in your textbook, I'm pulling examples from page 410. We need a formula, the sum of a finite geometric sequence. So, for a geometric sequence, defined as a sub 1 plus a sub 1 times r plus a sub 1 times r squared, dot, dot, dot. When we go all the way out to wherever we want to stop, r to the power of n minus 1, because this is our fourth term, so we want it to be raised to the third. When we go all the way out to here, that sum, you do need to write this down, s of n equals the first term times 1 minus the common ratio raised to the power of n divided by 1 minus r. And it's got a very cool derivation. If you look on the left-hand side of page 410, you can see the start of it, but I'm not going to do that here. It's a little bit beyond the scope of this class. You do need to know this formula though. So this is the sum of a geometric sequence. And when it's a sum, this whole thing, you could just say it's a geometric series. This is our first term. R, which appears twice, is our common ratio. And n is the number of terms. Okay, so a good idea to make sure this formula is working is check it on a geometric series that we could just add up ourselves. All right, so what's our a sub 1? Our a sub 1 is 2. What's our common ratio? Well, how do I get from 2 to 4, and then 4 to 8, and then 8 to 16? The common ratio is also 2. All right, and what's our n, the number of terms? 1, 2, 3, 4 terms. All right, let's plug this all into our formula and see what we get. So 2 times big fraction 1 over 2 to the 4th, or 1 minus 2 to the 4th over 1 minus 2. Let's see what we get. 2 times 1 minus 2 to the 4th is 16 over 1 minus 2 is a negative 1. 2 times negative 15 over negative 1. 2 times 15 equals 30. So that's what the formula tells us, is that it should be 30. Let's see what we get here. 2 plus 4 is 6. plus 8 is 14, plus 16 is 30. So this equals 30. So that checks out. All right, now let's try it with one that maybe we don't want to do by hand. The sum of this series from 1 to 12. All right, so this is geometric. We can tell because our exponent is, or our variable is in the exponent. But we might not be entirely sure what the a sub 1, what the r is equal to. We can probably tell that n is equal to 12 though, because that is the number up there. But to figure out a sub 1 and r, to just be certain about it, just start plugging in numbers in for n here. So a sub 1 is going to be 4 times 0.3 times 1 minus, or to the power of 1 minus 1. Well, 1 minus 1 is 0. So anything to the power of 0 is 1. So this here just simplifies down to 4, because this became a 1. 4 times 1 is 4. So a sub 1 is a 4. Okay, just to summarize that again, I plugged in 1 here, I simplified, I got a 4. Let's figure out what a sub 2 is. So 4 times 0.3 to the power of 2 minus 1. So 2 minus 1 is just 1. 4 times 0.3 is 1.2. So how much smaller did we get there? We could do 1.2 divided by 4, and we're going to get 0.3. And then when we see this, we should realize, oh, that makes a lot of sense for r, because this is the number that's being repeatedly multiplied. So now that we see that, we can always just say the base of the exponent is our r value. All right, we've got everything we need to plug this into the formula. So it's 4 times 1 minus 0.3 to the power of 12 all over 1 minus 0.3. All right, now when I plug this into my calculator, I'm going to do everything except for the times 4. I'm just going to do it in pieces. So 1 minus 0.3 to the 12, press enter, divided by, in parentheses, 1 minus 0.3, press enter, times 4. So I do it a little bit out of order, so I make sure I do my order of operations right. And I get, this here simplifies to be 5.714, which, you know, because these numbers are shrinking, that's okay, because it's going to be 4 plus 1.2. We're already up to 5.2, but the numbers are just going to keep shrinking. This next number is going to be plus a 0.36. So because these numbers are shrinking, that's why this number isn't all that large. All right. A few more. So here it just tells us the a sub 1, the r, and the n. And when it gives you this information, you don't have to do anything extra. You can just plug it straight into the formula. Let's just practice the formula again. All right, negative 4 times. I filled in the values where they need to go. You should practice plugging this into your calculators. Make sure you get the same number that I get. All right, negative 1. Did you get negative 2044? Okay, if you didn't, you must be plugging this in wrong. Go back and double check that you're doing your order of operations right. All right, and here's another way it can ask the problem. It just starts the geometric series, but then tells you how many numbers there are. Well, this isn't all that much harder because you get your a sub 1 from right there. It's your first term. And to get your common ratio, you could do a sub 2 over a sub 1 equals negative 8 over negative 2 equals 4. So that's our r. And there's our n. We got everything we need to plug it into the formula. Negative 2 times 1 over 4 to the 9th, or 1 minus 4 to the 9th over 1 minus 4. Let's plug that in. Minus 4 to the 9th divided by, I got negative 174,762. So 174,762 is the sum of that geometric series. Okay, we'll do more practice problems on the worksheet video, and have a good rest of your day.